If you're studying for the MCAT, this one's important. Atomic structure is tested in the chemical and physical foundation section. And three names keep showing up: Rutherford, Planck, and Bohr. Their experiments shaped how we think about the atom, from the nucleus to quantized energy to electron transitions. These models aren't just history lessons, they explain exactly why electrons behave the way they do, and the MCAT loves to test that. Rutherford, the nucleus. In 1911, Ernest Rutherford fired alpha particles at thin gold foil. Most passed straight through, but some bounced back. That deflection told him atoms aren't empty. There's a dense, positively charged nucleus at the center. This became known as the nuclear model. 2 years later, Niels Bohr refined it into the planetary model, where electrons orbit the nucleus like planets around the sun. Planck, energy is quantized. Max Planck, in 1900, introduced the idea that energy comes in packets called quanta. He gave us the equation E equals h nu, linking energy to frequency. This solved the problem of blackbody radiation and laid the foundation for quantum mechanics. The big takeaway for the MCAT: energy changes aren't continuous, they happen in discrete jumps. Bohr, quantized orbits. In 1913, Niels Bohr combined Rutherford's nucleus with Planck's quantum theory. He proposed that electrons occupy fixed energy levels around the nucleus. They don't spiral inward. They stay in stable orbits unless they absorb or release energy. Each orbit has a specific energy, and the lowest orbit is the most stable. Energy level transitions. When an electron absorbs energy, it jumps to a higher level, the excited state. When it falls back, it emits a photon with energy equal to the difference between levels. That's why hydrogen produces discrete spectral lines. Each one is a photon from a quantized electron drop. Limitations of the Bohr model. The Bohr model works beautifully for hydrogen, but it fails for multi-electron atoms. Real atoms have electron-electron interactions and more complex behavior. That's why modern quantum mechanics goes beyond Bohr. But for the EMCAT, remember, the Bohr model is your tool for understanding hydrogen spectra and quantized energy transitions. Rutherford gave us the nucleus. Planck gave us quantized energy. Bohr combined the two to explain electron transitions. These models shaped atomic theory, and they still show up in MCAT passages and questions. With that said, here are just a few of our student success stories. Students who mastered these concepts, boosted their scores, and got into medical school. If you're studying for the MCAT, click the link below to get started with your own prep. We help students reach a 515 plus on the MCAT, and we'd love to do the same for you. And don't forget, subscribe to our channel for more MCAT breakdowns like this, and follow us on Instagram for extra tips and resources.